avec nous. Bienvenue, Monsieur Allen. Merci beaucoup. Merci de l'applaudir. Please, right over here. Vous allez nous parler des solutions hybrides pour les constructions bois de grande hauteur avec les projets que vous représentez. C'est à vous. You have 20 minutes.
Okay.
Vous avez 20 minutes.
Thank you. First of all, thanks for the invitation. It's very nice to be here and see so many friends in the room, which I assume that you are. I come from a company called Moelven, and I'm based in Sweden at the Swedish glulam factory. But today I'm also representing our Norwegian sister glulam producer, Moelven Limträ AS. We're not producing wild animals, if any of you would think that, but we have produced buildings that these, what usually used to be wild animals live in today for zoos and such. But this picture shows basically what we produce in Töreboda. All sorts of supporting timber structures for all sorts of purposes. Today I'm going to talk about modern timber and hybrid systems and our way of handling that. Some more bread and butter products or projects, but also some a few iconic projects at the end. Mm-hmm.
Do you need some help?
I think so.
Okay.
I'm
Let
the
me
only
try
one
to
that
help
didn't
you.
manage the green button.
You
there
got
it
it.
is. Okay,
That's
thank
great.
you, thank you. Very brief. We're about 130 employees, and we design and produce all sorts of timber buildings, as I said. We have an in-house engineering office with about 15 structural engineers, and we're a part of the Norwegian Moelven group. The business areas, timber bridges, multi-story buildings, other type of sports arenas and things like that, and also products for the industry and retail market. The first question I would like to raise is this: should we work with solid wood, hybrids, or both? And we're not really making a clear stand on this subject, but we want to stress 5 important points. Number 1, we always need to make sure that materials are used for their best properties in each and every part of the building. We also should avoid overcomplicated technical solutions. We should utilize mass as efficient as possible and also reduce the total amount of material usage. That's very important. And also we should try and improve safety during the erection process. We have building sites now with very tall buildings, big heights and everything, so it's nothing that you play around with. You need to be careful. And this picture is from a project in Sweden that we were involved with a couple of years ago. And I think it shows and demonstrates pretty much what we're doing. Because you can see that there is a centrally placed elevator and staircase made out of concrete. And you can also see a steel truss frame to the left in the picture. And it has posts and beams out of glulam, and the floor elements and also the outer walls, the envelope of the building is made out of CLT. And we think that this is a perfect way of utilizing all different types of materials and different versions of wood in order to produce as smart buildings as possible. Some wooden buildings, I would argue, over-consume wood. We have some fantastic CLT buildings, fantastic buildings, nice in every way. But do we really need to use that much material in every building? I think that's a question that you should take home and consider. It's an important thing if we really want to do something for the environment in the long run. We have given this concept a name, and it's Trä-8, and in in English that translates into wood 8. Wood because it's a wood-based system, most wood, and 8 because we handle without problems 8 meters span width, which is quite a lot. Many buildings don't need more than that, so we cover most of the buildings that we get inquiries from. What it basically is that we use vertical posts and horizontal beams, and we stabilize the buildings with elevator shafts made out of concrete or CLT or trusses of glulam. By doing so, we utilize the properties of the wood in a perfect way, because wood is very strong parallel to the grain. Just think of how trees grow in the forests, and you realize why they're strong in that direction. So by using wood in this way, we have absolute minimal deformation over time in the vertical direction, which is nothing to neglect when you get with taller buildings. We always try to place this staircase or elevator shaft as central as possible if we can, if we have something to say about that. And we think that it's very good to use concrete for this purpose. And why is that? Well, all these buildings are very light. They are, compared to a full concrete building, it could be like 25% of the weight, roughly. So what happens if we get tall and we have huge wind loads, these buildings will fall over. And it's not enough to make them very stiff, because we can do that with a very stiff and strong envelope of the building, outer walls. But you will create huge lift forces in the corners of the building that you need to compensate for by many times adding concrete underneath the ground, digging big holes and pouring concrete in those holes, which is not what we really want, is it? So by utilizing some of that mass and extruding it to a functional part of the building, like an elevator and staircase out of concrete, we think we use the material in a smarter way. This is a picture from our factory where we put together a floor element, and this is basically how they are built up. It's a frame out of glulam, and it's a top slab of LVL. And this has a span width of roughly 8 meters, so it's pretty big units, and you can realize that we can make pretty, I mean the flexibility of the system is quite big, because we can make all sorts of different buildings, both commercial and residential buildings. The floor elements in details, this is a cross-section showing a very light and slender design. So there is not much material in this. And that is of course a challenge, especially when it comes to sound insulation, where mass is a very big helper. But the beauty of this is that they are extremely stiff, so they behave very well from a dynamic and vibration point of view. So by just fine-tuning with some additional techniques, the sound insulation is also very good. This is two pictures from erection process, and we always start by the elevator shaft, and we move outwards from that with the posts and beams, and then we put in these floor elements. And normally we try and cover the building with roof over the sections that we have mounted within the day. So we minimize the exposure of free water. That's very important. In Sweden we are very afraid of wet wood. We're not as afraid of that in the rest of Europe, but in Sweden it's a big thing. But we try to move all the way up to the top floor in one day, and then put the roof on top of it. This is how the floor elements are mounted in the glulam frame, and you can see that the overall height, if we're talking about 8 meters span width, is roughly half a meter, a bit more perhaps. And the underneath construction is double gypsum boards in a weak sheet metal profile to reduce vibrations. And on the top of the floor element we have a sound insulation board and 40 millimeters of concrete slab. That's something that we really need to have in order to get the right properties. But it's something completely different from adding gravel, concrete plates or huge slabs of concrete. So we think this is a pretty smart way of doing it. And again, using as little material as possible. Some more pictures from the erection site. This is a building that was completed in 2016 in Växjö in Sweden. It's a city that has been made famous for its high ambitions in timber buildings. These buildings have 2 stories out of concrete, a centrally placed elevator shaft and staircase out of concrete, and the rest with this Töreboda system. This is another building in Stockholm where we actually combine 2 building systems within the Moelven group. So the central part is made out of the post and beam Töreboda system, and the outer part, sort of the wings of the building, are made out of volume elements with fully finalized in the factory. It's an elderly home, so the residents, they live in the peripheral parts of the building, and the center part is for public areas like well, whatever they do, big living rooms and things like that. This is a picture from or a rendering actually from a building site in Skövde, close to Töreboda in the mid-south of Sweden. It's to be finalized in 2018, and we will build in total 10 buildings with 3 different buyers in this area, all with the Töreboda system. This is another picture of that. First floor made out of concrete, centrally placed concrete elevator shaft, and then the rest is posts and beams and wooden floor elements. This is an ongoing pre-study from Örebro, also close to where we are, and we get all kinds of these things all the time as we speak. So the market has virtually exploded in the last like 12, 18 months something. This is another building, and this was built by our sisters or colleagues in Norway. It's named Træt, for those of you who hasn't seen it. It used to be the world's tallest timber building, and it's in Bergen, Norway. It is a timber building, but it also utilizes the good properties of other materials in order to make the building. For instance, there are 3 stories with concrete slabs in order to improve the dynamics of the building. And they could, of course, have been made out of CLT, but with the loss of a lot of mass, which would not have been as good for this specific building. Glulam carries all the vertical and horizontal load, and it has been made very stiff, so maximum deflection at the top floor is 71 millimeters. When producing these buildings, we use CNC machines of the latest techniques, and we always pre-assemble the big trusses in our production facilities, making sure that the tolerances are perfect. So that's also a very good advantage compared to especially concrete, where this is basically impossible to achieve. And finally, maybe what will be the most famous building for a couple of years to come, Mjøstårnet in Brumunddal, Norway. It's under construction. It has a post and beam system with Töreboda floor elements. It's in total 81 meters tall. It has 18 stories. The footprint is 16 by 36 meters. And it uses glulam in post, beams and diagonals. But the top 7 floors has concrete slabs in order to achieve the right dynamic properties, slowing down the frequency when during heavy wind. And this structure is anchored to the bedrock 56 meters below ground surface, because you can imagine what lifting forces you will have here with such a small footprint. And this is my last picture, and it shows a cross-section of this fantastic building with all the 18 stories. It will hold a hotel, some flats, conference areas, and also a swimming hall. So I thank you for your attention.
Thank you so much, Mr.